Oxidative phosphorylation takes place in mitochondria. Oxidative phosphorylation can be defined as the coupling of electron transport with ATP synthesis, or the process of utilization of energy released during biological oxidation for the synthesis of ATP by phosphorylation of ADP. Energy-rich molecules such as glucose, fatty acids, and amino acids metabolized by a series of oxidation reactions, they yield carbon dioxide and water. The metabolic intermediates of these reactions donate electrons to specific coenzymes NAD plus and FAD to form energy-rich reduced forms NADH and FADH2. These reduced coenzymes can in turn each donate pair of electrons to specialized set of electron carriers, collectively called the electron transport chain, to oxygen, which is finally reduced to water. As the electrons are passed down the electron transport chain, they lose much of their free energy. This energy is used to move protons across the inner membrane, creating a proton gradient. The energy of this gradient is used to synthesize ATP by phosphorylation of ADP. It is a coupled process of oxidation and phosphorylation. The most accepted mechanism of oxidative phosphorylation is chemiosmotic theory. It states that the energy released from the oxidation of components in the respiratory chain is coupled to the translocation of hydrogen ions from inside to the outside of the inner mitochondrial membrane. Here the complexes 1, 3 and 4, they act as proton pumps. They can pump protons from matrix to the intermembrane space. So the inner membrane is actually impermeable to ions, particularly protons, which accumulate inside the membrane, creating an electrochemical potential difference across the membrane. This consists of chemical potential, that is difference in pH, and electrical potential. This electrochemical potential resulting from the asymmetric distribution of hydrogen ions creates proton motive force. ATP is synthesized when the protons flow back to the mitochondrial matrix through the ATP synthase. Thus, the oxidation of fuels and the phosphorylation of ADP are coupled by a proton gradient across the inner mitochondrial membrane. So here the phosphorylation of ADP is because of this proton gradient.